Number 5 in your classwork for Intro to 3D Figures, we have a hexagon or prism that we want to find the cross section for part A when it's between and parallel to the bases. So we're going to draw a plane that is parallel to the bases that falls in between them. So it's going to look something like this. So obviously the plane extends off to infinity, but we can model it as a sheet that goes through the prism, and that it is parallel to the bases. So it's like we took a knife and cut this in half. So we're going to get an image formed where we just slice this right down the middle. So that's going to form a hexagon of a cross section. So that is for part A, it will be a hexagon. Now, if we imagine for part B, I'm just going to move this over instead of redrawing it. We want to contain the diagonals of the bases. So what does this mean? The diagonals of the bases is when we have a vertex and we want to connect it to the point farthest from it to the other base. So this would be this vertex over here, and the corresponding diagonal to that would be on the opposite side. We would be on this diagonal over here. And notice that these diagonals are on the same plane, since these like imaginary edges that we've drawn here are collinear. They fall or are parallel. So we can draw in a plane that extends this time vertically and encompasses a rectangle that goes or lies on these two diagonals. So we would get a rectangle for part B. And now for part C, this isn't going to work out well if I erase this a little bit. We're going to mess it up, but okay, we'll just redraw that back in, no problem. So for part C, we want to take a intersection of all faces. So it's hard to imagine at first, but let's take the case where we had this plane that was intersecting parallel to the bases first. So when we had that plane, we formed the image of a hexagon on it. So it looked like this. And now, what would be the case when we took this plane and started rotating it about, let's say we chose a line like this, and we started rotating this plane in this direction. So this plane, as we moved further and further up, this plane would have an image of the hexagon, but it would just be stretched a little bit. So here it would lie more on a diagonal line, like so, and it would still fall like this. So it would look more of, let's say, diamond shape. Well, that's not the right word for it, but it would be more stretched. And we would eventually get to the point where this plane would meet this point and this point here. And if we rotate it even further past those 2 points, then our plane would intersect with the top and bottom faces. So we're going to redraw this figure again, because that one got a little messy. So if we have this hexagonal prism, now drawing the base, connected, Ta-da! We have our hexagonal prism again. If we then went ahead and drew in a plane that intersected like so. So let's get as precise as we can about this, because there's really only one very narrow solution where this plane intersects all 8 faces. So this plane would have to sit like this, coming through all of the faces. And if we imagine our cross-sectional area imprinted on this plane, it would stretch from this point on this edge to this edge here. Same for the bottom, so we would have an edge like this, and then we would have an edge coming from here to here, then from here to here, then from here to here. So that's already 1, 2, 3, 4 edges. This is the 5th edge. Now we have a 6th edge. We have edge number 7 and edge number 8 coming from here, which means if we have 8 edges, that would give us an octagon as our cross-section. Octagon, if I can spell correctly.